So, good morning. We are still discussing chapter 3. We will be first reviewing the discussion that we had last Wednesday. As a review, in the partial equilibrium model, again, talking about the linear model, in a static equilibrium model, the standard problem is to, again, find the set of values of the indigenous variable, and that is to find that is to find P star and also Q star, which will again satisfy the equilibrium conditions of the model. In the partial equilibrium market, the model of price determination in a single market is usually composed of three variables. We have QD, QS, and we have P. And because we reduced it into two equations, we only now have Q for both equilibrium quantities for those functions. The equilibrium condition is, again, QD is equal to QS, and our model setup would be equal to this one here. One way to find equilibrium, again, is by successive elimination of variables and equations through the substitution method. From equating those two functions, we have P star. We have an equilibrium price that is equal to A plus C over B plus D. The condition there must be the new denominator B plus D there should not be equal to 0. The equilibrium quantity can be obtained by substituting P star into either demand and supply functions. And again, we assume that AD minus BC or the numerator should be greater than 0 to make the model economically meaningful. We also discuss the partial equilibrium market model that can also be nonlinear. The model setup would then be equal to this one here. As before, the three equation system can also be reduced to a single equation by substitution. With this, we can solve by applying the quadratic formula, and then we have two roots: P star P star sub 1 equal to 1, P star sub 2 equal to -5. And we choose the first root because it is economically meaningful. We then proceed discussing the general market equilibrium, where we use first the parameters and the process we've discussed also. There's technically no economic analysis for doing shorthand symbols, or this is just parang an alternative way to help us save time and as well to arrive with a correct answer. So developing this method is, again, no economic basis, but more so a method to make the equations more organized, because dealing with 12 parameters would mean to say that we will need to parang transform or manipulate, and again, that we might commit some mistakes in just doing so. So the shorthand is just for convention, or just a convenient way to solve the case here. Again, as you can see, if we would arrive with we can then reduce the single equations into two. Then we can go ahead and do the same substitution elimination process. Isolate, just like what we did here when we isolate P2, and then we substitute P2 because we have an equation for P2 already. We can substitute it in the second equation in 3.16, leaving us with an equation to solve for P1 star. And we have a value for P1 star. We can solve P1 star in the equation here, and then we can arrive with a solution value for P2 star as well. It might seem daunting, class, just by looking at the parameters, but then again, I can assure you that the process is just the same, more or less, with that of the linear equation system or model. The restrictions also should be imposed just the same as discussed earlier. the denominator should also be non-zero, and the numerator must have the same sign as the denominator. Before I proceed to the numerical example class, again, just a review. When dealing with general market equilibrium, in a sense, kasi the partial market equilibrium is that it's only considering a single market. In the real world, again, it would normally exist a lot of goods or a lot of commodities, and a more realistic model for the demand and supply functions of commodity should take into account the effects not only of the price of the commodity itself, but also the price of the other commodities. So again, in a general market setting, there are, in terms of influences of price of one good to the other. So in this example, and the examples established here in the lecture notes, it's only dealing with a two-market commodity model. We have another example in this lecture slide, which is in this case here, a three-commodity model. You can do this one on your free time, but today the discussion is on the process of how to solve a two-commodity model. Okay. So again, the general market equilibrium model class is just an extension to the partial market equilibrium model, but just take note that price and quantity variables of multiple commodities in an N model, the condition would also be N commodity market model. Okay, so I hope you've seen the distinction between what a partial and what a general market equilibrium is. Okay, so let's go now to solving in a step-by-step process. Let me just turn off my camera. Okay, so let's now turn to the exercise here. So if you have a questions, just raise your hand. Okay. In this example, it's a two-market model. It's a market for beef and it's also a market for pork. So we are analyzing the relationship established here. Our task is to find the equilibrium conditions for each market, thus solving equilibrium price for beef and pork, and also the equilibrium quantity for beef and pork as well. We have not introduced other methods of solving, so we will resort back to using the substitution method. We have again two models here. The first one here is the model for beef. So these are the demand function for beef, the supply function for beef. The second model here discusses the demand function for pork, and we also have the supply function for pork as well. The equilibrium condition requires us to equate both functions in each market, starting off with the market for beef. So in this case, we just equate these two equations and then we simplify into a single equation here. We also did the same for the market for pork, equating these two equations and then reducing it to a single equation. Okay. Now we're left with two equations and two unknowns. So again, this is the equation for the market of beef. This is the equation for the market for pork. What happens after is let's take a look at this first equation in that is 3.20. What we need to do here is we isolate P. Isolating P would mean all the other variables on the right-hand side of the equation, and that's where we have this equation here. Okay. The next thing to do is that because we have an equation for the price of pork here, we'll just need to substitute this equation into 3.21, and thus we have this equation here. Okay. Then simplifying, we now have a solution value for the price of pork, which is equal to 5. Okay. Okay. What happens after is because we have the price of beef here, which is equal to 5, we can just substitute 5 into this equation to get the solution value for pork. So that means substituting 5 we will have the price of pork, which is equal to 3. Okay, so we now have the values for 5. We now have the values for beef. We now have the values equilibrium price for pork. Then we will now proceed with substituting these values in either of the functions in the beef market and also in the pork market. And so we're left with, so in this case, in the market for beef at a price of 5 and also in the price with the price of pork set equal to 3, 70 units are exchanged in the market of beef. In the market of pork, with prices set equal to these, 90 units of pork are exchanged in the market. Question about the process? So far, it's clear. Okay, so I think in terms of the challenges class, it's not much of the challenge kasi nga it's compared to just be dealing with parameters. There is no need to have a shorthand way of rewriting the equations because again, it's direct, it's straightforward. All you need to do is just to treat this one similar to that of a linear similar to that of a basic linear equation. So again, siguro the challenge would be on substituting the right values into the right equations. All right. Now, if there is no question, let's try to look deeper on the relationship between price and pork here. So I mean the relationship, either their complements or substitutes. Now we will also neglect the idea that these two commodities might not have a relationship at all, because as you can see here, the prices of these two commodities would also impact the quantity of the other good. Okay, so for example, in the demand function here, we can see that as the price of the pork increases, the quantity demand of beef also increases. So what relationship would that be, class? If tataas yung presyo ng pork, tataas din yung consumption ng beef. That would give us an idea that beef and pork are substitutes. Okay? Tignan naman natin ang second model, class. If tataas yung presyo ng beef here, tataas din ng consumption ng pork. So again, that cements the idea that these two goods might be substitutes. Okay? Because when we are talking about complements, kapag complements if the complements, or if these two goods are complements, then it would mean that if the prices of the other increases, if the price of one good increases, the commodity of the other good would also decrease, because again, these two are treated as complements. But for this example, because these two goods are substitutes, then they have a sort of indirect, they have sort of a tataas yung presyo ng isa, yung consumption ng isa din bababa, tataas din. Okay, so great. So question before I proceed to the other examples or the other section of the discussion. Okay, let me just check the chat box for a while. All right. So far, I hope my discussion is clear in terms of the process. Again, what are the things that we need to take note siguro? Number one is determining first what we're trying to solve. If we're tackle more on the equilibrium, it's understandable that we look for the equilibrium price and equilibrium quantity. The second thing to do is, again, to determine which market that we're working. So we know that this is a market for beef. We know also that this is the market for pork. How do we know that one? We look at the subscripts. So usually, this should supposed to be QD and subscript B. But then again, a subscripts would tell us if it's an exogenous variable or if what variable that is. That is either pork or beef. Okay, so usually there it would be an indication that B would stand for beef or P would stand for pork. Okay, the third thing to do is either if it's a general form, a general type, a parameter type kind of model, then you will need to do shorthand alternatives just to make your life simpler, or just to help you to manipulate the equations. Or if not, if you're left with a numerical example, you can just go directly and apply the equilibrium condition by equating these two supply and demand functions. And as far as that goes, you know the process already on how to solve linear equations. Okay, so I think that's much of the discussion on the general market equilibrium. Great. So there's also another example that you can try on your own. Again, much of the discussion on math econ is more on understanding the process. So arriving with the answer would be good, of course, but understanding more of the process, how the solution went, or how the sophistication of the solution would be, it's more of the concern of math econ. Okay, so you have these. In this case, I think the case is for complementary goods. So if you have two complementary goods, it means that if tataas yung presyo ng isang good, there would also be a decrease in the consumption of the other good. So again, on your free time, kindly solve this one on your own, and your solution values would be the ones written here. Okay. If there is no indication class that these two goods are substitutes or complements, again, you can just look at the equation. Just look closely onto the equations if it is positive or positive or negative. Okay. Also, in this case, it's a three commodity model. It might be hard to decipher if these two goods are complements or substitutes, but I think the concern for this one is how to solve or getting the values for a three commodity model. Okay, there's not much special process. I suppose if extending it to a three commodity model, the process is just the same. Okay, great. Question, class? All right. So if there's no question, I'll go to the general market. I'll go to the equilibrium in national income analysis. Okay, so right. Let's consider this example, class, because it's just first a basic model. So what we have here is a simple Keynesian national income model. We have Y and C stand here as our endogenous variables. So again, first and foremost, determining what we're trying to solve in the model. It's usually, in this case, we have national income, and we also have the consumption expenditure. So respectively, we also have we have investment and government spending as our exogenous variables. It is determined as our investment, and again, your government spending here. Let's have a more detailed process of how we solve those values. I think it is here. All right. Okay. All right. I think you're quite familiar already with the determining the national income. Let's try also to discuss the consumption function class. Okay. When you have the consumption function, we have A here, our parameter as our autonomous consumption expenditure. We also have our B here, which is the marginal propensity to consume. It is the fraction of $1 of income we spend on consumption. As a review as well, consumption function by Keynes says that consumers would purchase more at higher income levels. For example, if y is equal to 0 class, positive A here, which is greater than 0, tells us that consumers will not stop or don't stop consuming goods even if their income is 0. So that is still rationally correct, because even if y is equal to 0, it is possible that consumers still have savings to spend on. So they would not stop consuming at all. So that's the assumption there. If B is greater than 0, the consumers would buy more with more income. If B is less than 0, then that would be the amount that consumers would save. So let's tackle the analysis in a short while. Let's first discuss how we solve how we determine national income using again the same process as discussed earlier. So in solving equilibrium, in solving y star here, we have again, we first substitute the consumption expenditure function into the national income function. And then what happens after is we isolate y here, which leaves us with y star equal to a plus investment plus government spending over 1 minus b. The thing about solving y star or any solution value here, class, is that it should be expressed in terms of parameters and also exogenous variables. Moving forward to how we solve for C star, again, we have a value for y star there. All we need to do is to substitute y star into the consumption expenditure function, and then we will it will yield us with a C star. The problem the problem we might encounter, class, in solving a national income analysis is that it's more it's parameters. So we might should be reminded on how to manipulate or to simplify parameters, just like what we did here with C star. Okay. Then again, substituting y star into the consumption expenditure, we have C star already. One thing to take note as well is that the expressions here, the denominator, class, or the restrictions here should be that it will not be equal to 0. Okay. Question about yeah. So do we have a question, class, on how we obtain y star and also how we obtain C star? For a while. Okay, so I hope it's clear, class. Again, siguro to help us better build on how to solve the equations here, or to better build up our understanding in equilibrium, is first to review the theories that we have learned in 10 and in the prerequisites, and as well as what we've learned in Math 100 in solving those functions. Okay, so okay, here. Okay, now let's have a sort of activity, class, just a quick activity. Okay, so let's have this one. So I am showing to you a Word file. Again, that is from the exercise that we did just a while ago. Supposing we have specific values, class. If we have I is equal to 200, G is equal to 300, or government spending equal to 300, our A here, or our autonomous consumption expenditure is equal to 100. Our marginal propensity to consume is equal to 0.8, which is again B. The answer is already there. How we solve for Y star? Again, we just substitute the specific values to our reduced form already, and we'll end up with 3,000. So just what is left with our exercise here, let's try to compute the multiplier class. Okay, so let me just pause the recording. So to solve for the multiplier, again, it is just 1 over 1 minus B. All we need to do is to substitute, as Estrada mentioned, the multiplier is 5. How do we, what would be the economic analysis class when we have these values? So concerning ourselves with the multiplier first, that would mean to say that, right, let me just write it down. Or actually, I used this one earlier, right? So as an economic analysis class, if we increase government spending by 1 billion pesos, okay, suppose we have that much money. If we increase government spending by 1 billion pesos, Y star would increase by 5 billion times as much. Okay, so just a review class of what is a multiplier. So the simplest I think I can remember about a multiplier class is there is some form of a change that is going on. What I mean to say is that the multiplier is a product of the exogenous variable, and it would have an impact, or it will have an effect on the national income. Okay, so I think that is the simplest I can define what a multiplier is. So just like what we did here, if there is an increase in either of the exogenous variables, I, G, or I or G here, as for the example stated, any increase with that would have an impact on the national income.
Hey, ma'am.
Yes, Estrada.
Ma'am, may I add to the multiplier, ma'am, to the idea of the multiplier?
Yeah, okay, go ahead.
Ma'am, the reason why the increase in government spending and investment would result to a multiplier, because government spending and investment could instigate more consumption from the consumers. So parang that's the effect of increasing government spending and investment. It would push consumers to consume more of a product, precisely because there are more outputs that are produced, or consumers have the ability to buy outputs.
Right, that is correct. Also, just by looking at the national income function class, we go back to the kind of equation that is, and that is again behavioral equation. So that would indicate that there is whatever the behavior again in the exogenous variables, it would again create this chain. It will create this some sort of effect to the national income, and some of those chains are those given by Estrada. Okay, so again, it creates one channel or one chain. Could be possibly it would influence also the spending. There is government spending. It will also create this chain of spending on perhaps wages, or let's just say a chain could be wages on the government employees, and employees would also in turn use these wages to purchase other outputs, and again the whole notion of this chain. So right, thank you, Estrada. What else? What else? Great. So let's have so the let me just also add to the again to the multiplier on regarding the exogenous effect class. Again, if we will have to increase either of these variables, consumption, I suppose we have consumption there. If we have to increase consumption or investment or government spending, the question there is, by using the multiplier, how much would that national income would also increase? Okay, so again, it also pays to help that this is the review that we're doing is the multiplier in the simple Keynesian model. Okay. All right. Okay. Now let's going back to the discussion proper. Let me again also share it here. Okay. Now let's have another example, class. Okay, so let me just. Okay, here. Which side? Okay. All right. So having another example, still pertaining to the national income model. Yeah. Now, here's another exercise again. Suppose that we have this two-sector economy. We still have again the national income. We also have the consumption. We also have the consumption function here, and we assume further that the variables are. Assume further that y is equal to c plus I. We also have c is equal to c sub 0 plus py. We also have investment and some of the specific values. So if we're confronted with this problem, we can either solve this one in two ways. The first one is using parameters, and then we can use the reduced form to substitute specific values, or we can directly substitute these values into these functions here. So again, first thing to take note is to look at what are those values that are indigenous to the model. So, and we also look at those variables that are exogenous to exogenous to the model itself also. Okay. Let's proceed first in solving using general parameters. Again, we set the equilibrium condition. That is y is equal to c plus I. We substitute first these equations to the first equation, and then we're left with a single equation. We now solve for y. Solving for y would mean isolating y on the left-hand side of the equation, putting the other variables. These variables are, again, those exogenous and other parameters. That would mean to say that our solved y here, or y star, would be a reduced form. This is, again, expressed in terms of parameters and expressed of other exogenous variables. Okay. Before I proceed to the other one, do we have a questions, class? Do you have a question regarding how we arrive with this reduced form? All right. So what happens after is, because we have the reduced form already, again, we can just directly substitute the specific values into that, and then we will be arriving with y star equal to 1,400. Now, in another method, class, because we can also substitute the values directly to the functions, we can just go ahead, substitute these values here into the equation, to this function rather, and then we're left also with y star is equal to 1,400. Either way, either you do it in a reduced form or you do it directly, you will end up with the same answer. Okay. Do we have a question, class? So if you may have noticed, class, let me just go back to this one here. Okay. I thought I forgot I thought I forgot to provide some restrictions. But it's a good thing because every time we work in a model class, it's best to also look at what are the restrictions and what are the equilibrium conditions in that model. Okay. All right. Okay, let's go back quickly to that. All right. Now, in this exact exercise, do we have a question? Yes, Estrada.
Ma'am, I would like to clarify why there is why um Ma'am, I would like to clarify why there is no government expenditure in the solution.
Which part in this exercise?
Yeah.
Okay. Because in this exercise, we only have a two-sector model, we're only dealing with two sectors in the economy. And so that is a simplified version, which is only composing of consumption and investment. So that's why we are not dealing with government expenditures or spending because we'd reduce our analysis into a two-sector economy.
Okay po, ma'am. Thank you, ma'am.
Okay, so all right. So again, class, what we have here is again, you may have noticed that there are times that our analysis are reduced into a four-sector economy or a two-sector economy. There's also cases similar to this one here. There's also cases, class, that we've also deal with a simple Keynesian model with taxes. So, great. Right, did I not, let me just go ahead with this one here. Great. For this part of the discussion, we are trying to solve or how we're trying to explain how we arrive with Y star. And for your exercise later on, you can just do T star and C star on your own. Okay. So for a while, let me just also share. Okay. So let's start with again. So for those who, again, you can follow me, class. Again, how to solve. Let me just do it. Okay, here. Okay. Now, again, we are trying to solve Y star here. First thing to do is, again, to check on the model. What is our exogenous, what we are trying to solve? What are our endogenous variables, what we are trying to solve. So we have to confine only in the analysis in terms of those endogenous variables. And our endogenous variables are again Y, C, and T. We also have our exogenous variables. We have investment and government spending, which we will take that one as a given. We have our parameters. We have A, B. I suppose that I did not use any Greek letters there. But our parameters are A, B, D, and T. So ano bang ibig, how do we interpret these parameters? Let's take a closer look at the models or the equations. So in T, a T there, class, is again taxes. Okay. In that equation, T is equal to D plus TY. D there would be the intercept in that tax equation. So that would mean to say that that would be the level of taxes that is collected if national income were zero. Let me repeat. If national income is zero, if Y star is equal to zero, then D would be the level of taxes that is collected. Okay. Let's also, I think you're familiar already with, again, we've discussed the consumption expenditure function. what is y minus t? Y minus t is our disposable income. So disposable income, then that would be income after taxes. Okay, and our restrictions there would be that the values would be for A, that would be non-negative, that would be positive. For B, that's also be non-negative value. Okay. Great. What else? I forgot. I have overlooked something in the tax function there. So, the D again is our intercept. That would be the level of taxes collected. T, small letter T class. That is the coefficient on Y. In the tax equation would be the tax rate. So, if the tax rate, so let's have a number. If the tax rate is, say for example, equal to 0.2, then our analysis later on would be if y star would went by 1 peso, then how much would our taxes would go up by? Okay, let me repeat. T, small letter t there would be our coefficient, would be the small letter t is the coefficient on y, and that is our tax rate. So that is in our income tax rate. So if y star would went up by 1 peso, then how much would our taxes would be would go up by? Okay, so yun. So our point of concern today is how to solve y star. Okay, so we have already solved y star. So now is more on how do we get the solution for that, or what is the process for that. Okay, so again, you can do just C star on your own. Okay, what's the first thing to do? Okay, so let's pause the. All right. So we'll wait for a few more answers, and then we can state the answer. Okay. So I now have one correct answer. How about the others, class? What would be our multiplier?
Plus B times T. I think it's not the same as 1 minus B. Sa
Okay.
taas po, 1 minus B times 1 minus B times quantity 1 minus T.
Okay. Let me just try to interpret it, and let me know if I got it correctly. So you mean to say that this y star here is not the same as this one?
Yes, ma'am.
And
ma'am, actually, ma'am, parehas tayo ng sagot dito. Ma'am, dito po sa baba. Ma'am, pero nahihirapan akong gawing parang i-transform yung denominator nung sagot natin dun sa sagot. Ma'am, kasi hindi pwede, parang it's not possible for us to just factor out B there. Ma'am, parang yun kasi yung idea sa taas. Ma'am, parang it was just factored out.
Oh, yeah. Yes.
Ma'am, but I think it's not possible. Ma'am, parang hindi dapat. Ma'am, kasi it's parang it is parang 1 minus B plus B T is a whole entity. Parang hindi siya, hindi ko ma-explain.
Okay. All right. So the point of concern there was that it is not possible to just factor this one out because, again, these two are different entities. Is that correct?
Ma'am, dun sa baba. Ma'am, ma'am, parang 1 minus B plus BP. You can factor out B there para maging 1 minus B times B plus BP.
Okay.
Or pwede. Kasi I tried substituting some values for A, B, D, and T. Dun po sa sagot na nakuha natin. Doon sa sagot sa taas.
Okay. Okay, let me ask you then. So it's more on how we will be emphasizing the multiplier as is. What is not possible?
Ma'am, for us to factor out B from the equation, from the expression, 1 minus B plus BP. Kasi walang B dun sa 1. And you can you can just do that dun sa minus B plus BP kasi merong 1 doon. And I tried substituting, for example, A, for example, A is equal to 2, B is equal to 3, B is equal to 4, and P is equal to 0.1. I tried substituting it to both equations and it yields to different answer.
Okay. So, well, okay, let's start first with the basics. Did we try, what I did here is to find first, yung common denominator. And that's how I emphasize the multiplier.
Ma'am, what do you mean by common denominator?
I try to treat this one as to I try to disintegrate both, and so that's why I will have to look for the common denominator first. So to be frank, actually did not do any substitution at all when it comes to manipulating Y star there. I just tried to look into how do we isolate the multiplier, and by doing so, I got I just got the common denominator of the two.
No, ma'am. What I mean by substituting some values is for me to clarify if the answer that we got, y star is equal to A minus B, B plus I plus G is equal to that equation. So I tried to check if it's the same by substituting some values.
Okay. So you tried first to check the values if it's the same for this one and it's the same for this one. Am I correct?
Yes, ma'am.
Okay.
But it's not the same.
Oh, okay.
I think 1 minus B plus BP is not the same as 1 minus B times quantity 1 minus T.
Okay. That's what you're trying to say.
Yes, ma'am. I'm sorry if
okay.
I got you confused.
Okay. Sige. All right. Sige. How about siguro I'll send it via the lecture notes my explanation, because I think what I did here for Y-star is to have some I actually did some shortcut here, so that might providing an explanation to the shortcut would explain why the values might be different or might be the same. Okay, so let's have that one para we can have a full explanation on why the values are that. Okay, would that be sufficient today para I can come up with a good explanation in the lecture notes?
Yes, ma'am.
Alright, sige.
Ma'am, actually, I also got the same answer, ma'am, yung dito sa baba, ma'am, but I can transform it to the answer dun sa taas.
Sorry, what was that?
I had the same answer dito sa dito po sa ginawa nyo kanina.
Okay.
But, yeah.
Alright, sige. Sige, let me just write it down where I can focus into that one. Okay. So for now, I'll go back to your question, Estrada, and then I'll present that one with a good explanation. Okay, explaining not the shortcut version.
Thank you, ma'am.
Okay, thank you for raising that. Kahukom, do you have the same concern?
Ano lang po, yung sa equation po na sinasabi ni Estrada po. I think tama po yung equation sa taas and sa baba kasi I arrived the same equation po for both.
I don't think I can hear you well, Kahukom.
Hello, ma'am?
Yes, you were saying?
I think po, kaya lang po nagkaroon siguro po ng confusion si Mr. Estrada with the arriving the solution in the Y star is because kinonsider niya po yung 1 minus B as a whole entity po. So, kaya po nagkaroon dun sa taas ng confusion. I've arrived po both answers po.
Well, that might help. That might be a help to an explanation, but I think that what Mr. Estrada wants is more of a theoretical basis, which would also be an important factor. So yeah.
Yes, ma'am, kasi I think tama naman na 1 minus P shouldn't be shouldn't be considered as one quantity. But what I'm asking is that how was B extracted from the expression 1 minus B plus BP? Is it possible for us to extract minus B plus BP?
Well, I think that is well, to say the least, without mentioning any theoretical basis to that, I think that has been a practice, and that is in most cases acceptable in mathematical theory. So yes, we can dissect it without treating the other without considering if it's a one entity or not. So
no, it's still the same.
All right, I think that this is where the theory would play. to help us explain, no? Because I think that just the explanation of do we do it just out of convention or just do we do it because it's a practice, I think what can answer our question, no, we will always go back to mathematical theory. Okay, so which I'll plan to have by next meeting siguro. I think that it would also help us, not only me, to help us not only you, not only you or me, but also to me, to remind on the mathematical theory that is mostly the basis of our answers in linear equations. Okay, so I think we can put our this discussion into we can sum up our discussion, and then we'll go back to this one when we can review the theories. Okay, so right, so thank you, Estrada, for pointing, and also Kahukom for providing also the insights. We'll go back to this one next meeting. Okay, I think we're short of time today. Okay, but aside from that, I think that the discussion is I think the discussion in equilibrium is appears to be clear. Probably we'll just concern ourselves siguro on reviewing the theories behind the theories behind those that we've discussed today. Okay, so aside from the ones pointed out, do we have other questions before we call it a day? Okay, so I think that silence means no question. Sige. All right. So, well, I wouldn't say that today has been a bit easy, but I think this is something that we've always we've somehow missed in a typical discussion, classroom discussion. So we'll go back to the questions that we have right now. I mean, that we have posted earlier, and then we'll go back to that one next meeting. Okay. Yeah. All right. So next meeting, after we're done discussing the points that we make it, the points here, we'll go to chapter 4, which is matrix algebra. So matrix algebra, just an overview. It's more of a method. So it's not something that is new, I think, but it's an alternative on solving simultaneous linear equations. Okay. So I think that I can just check VLE every now and then for the lecture notes on 4 because I might be focusing on some points, only on some points siguro sa chapter. Okay? All right. So that's it for today. Thank you for joining the class. Kasi nga class, yung siguro mga 8 people na lang or 9 people na lang ang nagjo-join sa klase. But anyway, I expect the same people, the same level of participation next week. That's it for today, and you can you can already leave.